Hello, this is the third and final part of the WEAP 1 hour video tutorial where we are seeing how to create a model from scratch. We have already created the area, entered GIS layers into the model and added the elements. We saw how to move the labels of the elements, the options available in WEAP to enter information and define the general parameters of the model. We will now enter the data to each WEAP element, run the model, and explore the results graphically and in tables. This exercise is similar to the one in the WEAP in 1 hour chapter of the WEAP tutorial. We are going to continue with the exercise. We were talking about the head flow variable for the main river. We saw the options available to enter data into WEAP. Considering that we have the multi-annual monthly average flow, the right option would be the monthly time series wizard. We can copy the expression from the Excel file monthly values. Enter the head flow variable, delete what is there, and paste the expression. Enter. The main river now has the supply assigned, the multi-annual monthly average flow. If we go to the reference scenario, we see that every January has the same stream flow. It will be the same for each month. We will continue entering the rest of the information for the big city and agriculture demands. We follow the same process. We must select the variable to edit and enter the information. Here is the information we have for each demand. We are going to start with the big city. Right-click on the big city, edit data, and select the variable. We want to enter information to the annual activity level. We are redirected to the variable annual activity level for the big city demand site. If we click on the demand sites category, we can see the annual activity level variable for all demand sites simultaneously. To enter information in the annual activity level variable, we must first assign the unit according to the demand type. No information can be entered until you set the unit. For big city, the unit is people, and it is hectares for agriculture. In the case of hectares, it is an area unit. WEAP has several options available. We must go to the area category and select hectares. Once the unit is set, the box is enabled and the information can be entered. In this case, the data has no variation. It is a fixed number. Therefore, we do not have to use any function. We can type it. Enter 800,000 people in the annual activity level variable for the big city demand. Be careful with the zeros, the variable and the element. Always check the variable and the element where you are entering data. Enter 100,000 hectares for the agriculture demand. It is the same procedure for assigning the value of the annual water use rate. Select the demand sites category. It is easier to visualize the variable for all the demand sites at the same time. Enter 300 cubic meters per person per year for the big city demand. 3,500 cubic meters per hectare per year for the agriculture demand. The annual water use rate unit is automatically set depending on the annual activity level unit. I can change the volume unit, but this one is set from the annual activity level variable. We keep moving forward with the monthly variation. The demand sides have this monthly variation by default. This behavior depends on the time step boundary, which we set on the years and time steps window. Because this is a monthly model and we select based on calendar month, each month has assigned a monthly percentage based on how many days a month has. For example, January has 31 days. 31 divided by 365 days equals 8.49%. It will be the same for each month. The monthly variation variable is used in WEAP to distribute the annual water use rate within each month of the year. The big city demand does not have a different monthly variation. The agriculture demand has it. We can use the Excel file monthly values. Enter the monthly data, then copy and paste it into WEAP. Go to the variable, delete what is there, paste, and enter. We have assigned the monthly variation of the agriculture demand. Finally, we are going to enter the data for the consumption variable. Select the demand sites category and go to the consumption variable. It is important to verify which demand site we are entering information. We will be entering data for Big City here and here for agriculture. Enter 15% for Big City and 90% for agriculture. All available data were entered into the model: annual activity level, annual water use rate, monthly variation, and consumption. This is a simple model, and we do not have further information. For example, losses or capacity for the transmission links, or distribution losses for the demand sites. In WEAP, it is possible to characterize in detail the supply or demand elements. We can do it depending on the information available. Go to the Results view to run the model and explore the results. Once we click on Results, WEAP displays a confirmation window. Results are out of date. Do you want to recalculate it now? Results are overwritten each time the model is run. Sometimes new data are entered, and you want to verify or export previous results before obtaining new results. If that is the case, you will select No on this window, and WEAP will allow you to explore the latest available results. There are no previous results, and if there were, we would like to update them. Select Yes. WEAP shows the last explored result, so that you may see something different right now. You can access the results through this drop-down menu. The results are classified into these categories: demand, supply and resources, water quality, financial, and input data. If you access any category, for example, demand, you will see a list of the available results, such as demand, supply requirement, supply delivered, unmet demand, and coverage. Under the supply and resources category, we will have, for example, river stream flow. Depending on the modeling interest and data entered, we can explore different results. We are interested in evaluating the water demand and stream flow results. Go to the demand category and select the water demand results. The water demand for the big city and agriculture is shown. Once we select the variable, you can set the rest of the options on the graph. For example, the unit. Change the unit to cubic meters per second by using the third drop-down menu. We can also aggregate the data. For example, monthly average. You can view only one month by selecting the month from this drop-down menu. You can choose to see only the results for each demand site. only the big city, or only the agriculture, or both. There are several options for displaying the results. Remember that the objective of developing this model was to answer these questions. For example, what is the annual demand per water use? What is the total annual demand? In this case, we need a volume unit to be able to aggregate the variable. Set the unit to cubic meters. Depending on the magnitude of the results, WEAP can assign a different notation. In this case, millions. This notation can be modified in the second drop-down menu. To see the values, we can go to the table. Select annual total to aggregate the results. We see that the demand for agriculture is 350 million cubic meters per year, and for the big city is 240 million cubic meters per year. The total annual demand is 590 million cubic meters per year. Other questions were, what is the monthly demand per water use? What is the total monthly demand? Select monthly average. In January, the demand for big city is 20.38 million cubic meters. February, 18.41. March, 20.38 million cubic meters, and so on. For agriculture, remember that this zero is due to the monthly variation. It did not require water in these months. We can see it as a chart or a table. Another question was, what is the coverage per water use? Go to demand coverage. Here we see the graph. You can see it in 3D by selecting this 3D option from the menu on the right. Sometimes this is useful because the results are overlapped. It is easier to see them in 3D. Select monthly average. We can see that the coverage for big city has a deficit in February. Both demands have a deficit in August and September, and big city in December, because the stream flow is insufficient to meet the demand. We can see it in the chart. It is up to 92% in February for the big city. Both demand coverages reach 68% in August and 92% in September due to the demand priorities assigned. It is up to 92% in December for the big city. We model agriculture to only require water from March to September, so it registers 100% coverage in the December and February shortage because it has no water demand. Another question was, what is the downstream flow of the city water intake? Go to Supply and Resources, River, Stream Flow. The stream flow is shown in each of the ridges. The stream flow at the main river headflow is the data entered in the headflow variable. Subsequently, in the next ridge, the stream flow decreases due to the withdrawal of big city. In the next ridge, it decreases again due to the withdrawal of agriculture. Then, the stream flow increases due to the water discharge of big city. In the last ridge, it decreases again due to the water discharge of agriculture. If we want to explore the values, it is easier to go to the table. WEAP assigns the ridge name. We can check the location of the ridge's name, withdrawal node 1, withdrawal node 2, big city return, agriculture return. Go to the schematic view. The names correspond to the nodes on the river that represent withdrawals and return flow. Right-click on the node to verify the name. We'll draw a node 1, we'll draw a node 2, big city return, and agriculture return. It is important to check the names so that you can explore the streamflow results properly. Additionally, you can copy the chart and paste it into reports. Right-click on the graph, copy, and paste it, for example, in Word. We have already answered the question with the help of the results in WEAP. You can explore the results of this exercise in detail to understand them, considering the input data.